This course will take you through the basic properties of sound. The two most common terms, frequency and intensity, will be explained and related to hearing in humans. To investigate what sound really is, let's take a look at the following example. When a stone hits water, ripples spread in circles. The ripples are created by movement of the water molecules. In the same way, the stone creates waves or pressure variations in the air when it hits the tile. Different materials create different pressure variations. This means that the properties of sounds heard depend on the physical properties of the material generating the sound. The pressure variations are often illustrated with a tuning fork. When a tuning fork is struck, the arms of the tuning fork move and the air molecules around it will start to move back and forth, or vibrate. The back and forth movement of molecules results in an increasing and decreasing of the air pressure. This generates a so-called sine wave, which is also known as a pure tone. A basic dimension of sound is frequency. Frequency refers to the number of times the sound waveform repeats itself per second. This repetition is described as cycles per second. Thus, frequency is measured in cycles per second, or hertz. High-frequency sounds have many cycles per second. This is also called high pitch or treble. High-frequency sounds are critical for speech understanding, since most consonants are found in this area. Low-frequency sounds have fewer cycles per second. This is also called low pitch or bass. Vowels are mostly low frequency. Low-frequency sounds are also important for the general sound picture. Not all air pressure variations are perceived by the human ear as sound. Research has shown that the human ear is able to perceive sounds as low as 20 hertz and as high as 20,000 hertz. As an example, a musical instrument like the organ would cover the entire frequency range that humans can hear. Birds singing can be an example of the higher frequency range, and traffic noise covers the lower frequency range. The loudness of the sound is called intensity, or the amplitude. This describes the size of the sound wave. It is measured in decibel sound pressure level, abbreviated dB/SPL. A low dB/SPL value corresponds to a soft sound, while a high dB/SPL value corresponds to a loud sound. Leaves rustling in the wind create a sound pressure level of about 20 to 25 dB/SPL, normal speech about 55 to 65 dB/SPL, and a jet engine up to about 140 dB/SPL. To illustrate the relationship between frequency and intensity, please look at this graph. On the x-axis, you see frequencies, and on the y-axis, you find the intensity. Please watch the red dot and listen to the changes in sound. But what levels can the human ear hear? The answer is illustrated by this graph. The graph was created to determine how much sound is needed for a person with normal hearing to just hear it. This has been done for many frequencies. The resulting curve is the average threshold of hearing. As the graph shows, we are able to perceive very low levels in the frequency region from 500 to 4,000 hertz. Many speech sounds have these frequencies. In the low frequency region from 200 to 500 hertz, and in the high frequency area from 5,000 to 10,000 hertz, our hearing is less sensitive. This means that sounds need to have a higher intensity in order for us to hear them. If we raise the intensity 10 dB/SPL at 1 kilohertz, and then ask the listener to tell when they feel that the intensity is equally loud at other frequencies, we will be able to plot down this curve. This way, a series of curves with different intensities at different frequencies have been made. Because these curves show significant variations of the intensity, even though the listeners experience the sounds equally loud, they are called the equal loudness curves, or in technical terms, the Fawn curves. As an example, the 40 Fawn curve is showing a series of intensities at different frequencies that are perceived as equally loud by a person with normal hearing. The loudest intensity which has been recorded is 120 dB/SPL. For someone with normal hearing, this intensity will be uncomfortably loud. This limit is called the uncomfortable level, or abbreviated the UCL. Knowing the UCL is important when fitting hearing instruments, since amplification should never exceed this level. We have now determined an upper and a lower limit for a person with normal hearing, an upper limit of 120 Fawn and a lower limit of 0 Fawn. Within this range, a person with normal hearing is able to perceive sounds. Research has shown that people with normal hearing find intensities around 60 Fawn as most comfortable. This is called the most comfortable level, or abbreviated the MCL. Knowing the MCL is also relevant for hearing instrument fittings. When prescribing amplification, it should not only be audible, but also comfortable for the client. With the equal loudness curves, we have established an overview of the intensity range the normal hearing human ear is able to perceive, ranging from threshold to most comfortable level and uncomfortable level. You have now been introduced to the basics of sound and the two most common terms, frequency and intensity.